In this video, we're going to take a look at the different kinds of canvases that we can use to create our GUIs. So there are really three different kinds of canvases. The first one we've already seen, and that's the screen space overlay. Basically, all it does is it takes whatever's in that canvas, whatever UI elements happen to be parented to it, and it displays them overlaying everything else on the screen. Basically just how the old GUI system used to work with the onGUI method. The second kind of canvas allows us to attach a canvas to a camera, which is really powerful because it allows us to actually have a perspective projection on the UI elements themselves. I'll show you guys the difference between that and the typical orthographic projection here momentarily. The third type of canvas is going to be the world space canvas. The world space canvas is pretty interesting in that it allows us to place the canvas in actual three-dimensional coordinates within our scene. So we can place a canvas, for example, next to a character, and have the canvas project its UI into a space that we define around that character in the actual world itself. So a question that some people may be asking is if we can have multiple canvases per scene, and the answer to that, of course, is yes, because you would typically, in an actual game scenario, you would typically have a canvas that gave you most of your UI elements, for example, your HUD and your weapon selection, all that fun stuff, and that would be a screen space overlay or a screen space camera projection. And on top of that, you would have a variety of other canvases positioned within the world that provide different UI elements for three-dimensional objects. So in this video, we're going to look at all three of them, what their differences are, and how to configure them, as well as some really common pitfalls you can run into while using them. First canvas I want to show you guys you've already seen, but I'm going to put it up here just to show you guys some of its limitations that we didn't cover in the last video. So I'm going to come over here to the hierarchy, and I'm going to right click and create a new, under UI, I'm going to create a canvas. And so our canvas, I'm going to make sure it's not a child of the main camera. This canvas is going to be a screen space overlay canvas, and we can see that right here on the right hand side under render mode on the canvas component. You'll also notice some other interesting properties of the canvas. Like I mentioned in the last video, you'll notice the canvas is very large. And the reason for that is the canvas's size is actually determined by the size or the resolution of the camera or the main camera that's used to render our scene. So again, just like in the last video, we can change the size of this canvas by simply changing the resolution of the screen. You'll notice that in this case, this is being determined by pixels, and we can see that by looking at the rect transform and noticing the width and the height correspond to the pixel values of the resolution of the camera. You'll also notice that they're grayed out, and that's because we can't actually position or scale the canvas at all, or even rotate the canvas at all. A screen space overlay canvas is pretty much an abstract concept that'll exist in our scene, and no matter where it looks like it exists physically, it's actually always going to be painted onto the camera in the exact same way. So regardless of where this canvas is located, it's always going to be positioned somewhere. It's always going to be displayed on top of our view. So we don't need to worry about modifying any of the rect transform. So you might be thinking, well, this looks pretty cool. Pretty straightforward, very simple to use, but unfortunately has some drawbacks. In particular, the screen space overlay canvas will only support an orthographic projection. So if you recall from maybe earlier Unity videos that you may have watched or your own experience, an orthographic projection is a projection that removes depth from what we see. So what that means is we're going to get some really weird looking behaviors when we try to rotate and move our UI elements. So let's go ahead and look at some of those behaviors. To demonstrate this, I'm going to right click on the canvas, select UI, and create a panel. Then I'm going to anchor the panel on the right hand side of the screen by clicking on this rect transform, holding down Alt and Shift, and let's just go ahead and click on this guy right here. Now that we've pivoted the panel on the right hand side of our canvas, I'm simply going to resize it using the rectangle tool by hitting Y on my keyboard. And then I'm going to move it down. Then I'm going to, I'm not going to type in these values, I'm just going to eyeball them, because we really just need to see kind of a general idea of what's going on here to get the gist of what I'm trying to show you. Then on this panel, I'm going to right click UI and create a button. I'm going to create a couple buttons. So I'm going to create a button here, then I'm going to hit Control D, drag down, create another button, Control D, drag down, create another button. I'm doing this again just to give us some sort of visual feedback for what we're about to show. Now that I've done that, I'm going to move my game window in to be next to my scene view so that we can watch the effect that rotation has on this panel. Because you'll notice that when we're in our scene view and when we're in our normal 3D view, these UI elements look very deceptively 3D. In fact, they are. You won't notice that if you're in the 2D mode, obviously, which is handy for a lot of different things, but when you're in the 3D mode, you definitely see that these are 3D objects, which would lead a person to believe that we can rotate them and move them as if they were 3D objects. So let's go ahead and select our rotation tool and grab the y-axis and kind of pull it and see what happens as we rotate. You'll notice something really bizarre looking. In fact, I'll go ahead and make this more apparent by centering my scene view in a similar manner to my game view. Now my scene view shows you an example of a perspective camera, whereas the screen space overlay type of canvas will always be rendering as an orthographic projection. Now watch what happens as I rotate this panel along the y-axis. You'll notice that it does not give us the behavior that we want. Furthermore, if I were to move this panel along the z-axis, and in this case, because it would be very difficult for me to grab that handle right there, I'm going to do this inside of the rect transform itself by coming here to pose Z, or position Z. Watch what happens as I bring it forward or backward. You'll notice that the orthographic projection of the screen space overlay canvas is effectively chopping the z-axis off, and that's actually a really good description of what orthographic cameras do in general. You'll notice in the scene view, since I have a perspective camera, I can actually visualize the element going backwards and forwards. So this is going to be the primary limitation of the screen space overlay canvas. And again, it's very straightforward and easy to use, but it will lack a certain amount of features that allow you to create certain effects that you might want in your game. Particularly three-dimensional user interfaces are actually becoming quite popular these days. So we might want to be able to look at an alternative canvas type in order to support those features. So what I'm going to do is I'm going to leave this canvas where it is, because I want to be able to show you guys a side-by-side comparison of the two forms of canvases besides the world space. So I'm going to go ahead and move my game window off to another monitor so we can focus on the scene view for now. And what I'm going to do is I'm going to create a new canvas. So I'm going to right click in my hierarchy, hit UI, and go down to canvas. Now I have a second canvas, and you'll notice that's positioned pretty much identically with the first canvas, because again, this is also going to be a screen space overlay. However, I don't want it to be a screen space overlay. In this case, I want to be able to take advantage of perspective. To do that, I'm going to need to use a different kind of canvas. So I'm going to come over here to the canvas component, and under render mode, I'm going to select screen space camera. Now, at first, it might not look like a whole lot of things changed. So I can come up here and I can create a panel, for example, and I can I'm going to go ahead and dock it to the left-hand side, select my rect tool, move it in a little bit. And so you'll notice that now I have another panel, and this other panel is in a different canvas. And this canvas has a screen space camera selected. And if we look at our game view, we'll notice the exact same nasty orthographic behavior that we are trying to avoid. So what's going on here? Well, like its name implies, the screen space camera canvas type requires that we give it a camera. So what I'm going to do first is I'm going to assign the screen space camera to my main camera. And I'll leave it there for now, and we'll shortly find out why we might not want to do that. But for now, it'll give us a really good overview of the perspective versus orthographic display. So over here on the render camera, I'm going to click this little circly doohickey, and I'm going to select main camera. you'll immediately notice something change in our scene view, which is really interesting. You'll notice that not only did our canvas shrink significantly, but it also moved. What actually happened was it now constrained itself to the frustum of my camera. If I click on my main camera, is it really not going to show me the frustum? Oh, I have to open up my camera, don't I? Okay, we can see the frustum of the camera, and we can also see the canvas that I added to it. So what's going on here is the canvas is now constrained within the camera, and furthermore, this canvas is only going to be displayed by this camera. So you'll notice that I can move the camera around, and the canvas still moves inside of the frustum of the camera. I can rotate, and it moves along with it in any direction I want, and so on and so on. So what's cool about the WorldSpace camera is that I can now take advantage of the perspective properties of this camera in my UI. We can see a good example of that by first coming up here to this panel and adding a couple buttons to it, just like what we did before with the other panel. So I'm going to add a button to it. I'm going to duplicate the button a couple times, just so we can see this effect a little bit more pronounced. So now what I'm going to do is I'm going to move my game window over here so we can see both the game view and the scene view simultaneously. Now watch what happens as I rotate this panel when inside of a screen space camera canvas type. You'll notice that its perspective is actually correct. Just as a reminder, if I were to do the same thing to our canvas overlay, the perspective is not correct. In addition to being able to modify the rotation of our UI elements inside of a screen space camera canvas type, we can also modify its z-axis. So I can do that here by taking this pose z attribute and moving it forwards or moving it backwards. Notice that it now has an effect. Previously it had no effect on the screen space overlay because the screen space overlay had no concept of the z-axis. But now that we're in a projection, or a perspective projection rather, we can see that effect. So this can be used for a variety of different really cool animations and a whole bunch of other cool stuff, because I could even come up here to one of these buttons, for example, and take its Z position and move it forward a little bit, giving a nice little effect of popping out of the panel itself. Okay, so now that we've done that, let's talk a little bit more about how the screen space camera projection can actually cause some problems. So what I'm going to do here is I'm going to create a three-dimensional object. So again, remember, the canvas is placed inside of the camera's frustum, and it's going to be placed somewhere between the near clipping plane and the far clipping plane. Now watch what happens when I introduce a three-dimensional object to the scene. For example, a cube. Now what I'm going to do is I'm going to make this cube really big along one axis and another axis. And now watch what happens. You'll notice that I can actually clip the three-dimensional object through the camera. Now the screen space overlay doesn't matter. The screen space overlay will always render above everything else. But the screen space camera allows me to clip these 3D objects through our UI, which might not be what we want. Now there's a couple ways around this. First of all, I could come back here to my canvas and I could change its plane distance. The plane distance basically affects how close the UI is going to be inside of the camera's frustum. And you'll notice that it allows me to place an item or place the UI behind or in front of a three-dimensional object. Now this might be a cool feature. I'm sure that that you could use this behavior to some good effect in some situations, but I'm willing to bet that commonly it's not exactly what you're looking for. So what we're going to do instead is we're going to take a look at how we can introduce a second camera to prevent our UI from clipping into our three-dimensional world. To do this, first thing I'm going to do is, well, create a second camera. So I'm going to come over here to my hierarchy. I'm going to right-click, and then I'm going to come down here to camera. Now, when you create a second camera in Unity, it's important to remove things like the flare layer, the GUI layer, and the audio listener. So I'm going to remove all three of those components and effectively leave this game object with only one important component, being the camera itself. So if you've ever worked with Unity cameras before, I mean, there's fun stuff you can do with them, I guess. So you can see that right now, this camera is actually overwriting my other camera, and we can't see anything on the other camera. We'll go ahead and address that here momentarily. The first thing I want to do, however, is come up here to the canvas, the screen space camera canvas, and drag our new camera onto its render camera. So now you see that just like before, our camera is attached, or our UI is attached to our camera, but we're still suffering the exact same problem with our UI clipping through elements. Now the reason, what's going on here is that this camera is actually completely overwriting all of the pixels that are being rendered by this camera. Like completely overwriting. So to fix that, what we're going to do is we're going to come up here to camera and we're going to set our clear flags to depth only. What that allows us to do is it allows us to see both of our cameras at the same time, with only one camera providing a background color. But now you'll notice another problem. As you can see, this box, we only have one of these boxes, but it's being presented in two cameras. So we're effectively seeing it twice. To fix this, I'm basically going to constrain this camera to only displaying the UI. So I'm going to come up here to its culling mask, and I'm going to say, from everything, I'm going to click on nothing to clear out all of these other things. Then I'm going to click on UI. Now you see what's happening is this camera, this second camera, is only displaying the UI. It's not displaying the three-dimensional world, whereas this camera is only displaying the three-dimensional world and is not displaying the UI. If you do not see this behavior, it is possible that you have accidentally changed the layer that your canvas is located on. Now it's not really, there's no magic going on when I click the UI on the culling mask. In fact, what that's doing is it's culling out everything but the game objects that are located on the layer of UI. If we look at this canvas, we see that it's on layer UI. Now watch what would happen if I change this to default. In addition to changing the canvas to default, I'm also going to change all of his children to default as well. You'll notice by doing that the UI disappears, and that's because this canvas is no longer on the UI layer, and therefore no longer being rendered by our secondary camera. Again, to resolve this issue, you're going to have to come up here to your canvas and make sure that it's on the UI layer. In addition, you're also going to have to make sure that all of its children are on the UI layer as well. Anyway, by performing these steps, we now have a secondary camera that I can position anywhere in the game world I want. Like I can throw it all the way, over there, I guess, to not get in our way, or I can leave it near the origin so we can have quick access to the UI from it. Whichever way you want to go, it doesn't matter. The position of this camera is irrelevant, and it's not going to display the 3D world. It's only going to display the canvas that's associated with it. So again, I can accomplish a lot of cool effects, but now my screen space camera UI will always display in front of all of my three-dimensional objects, which is typically going to be the behavior that you're looking for. Now let's look at one final example of the third type of canvas that you can create, and that's going to be the world space. For this example, I'm going to empty out these two canvases of UI elements because they're no longer necessary to demonstrate anything. So again, I'm just going to come up here to this panel and I'm going to remove it, And then I'm going to come here to this panel and I'm going to remove that, effectively leaving both canvases blank. So what I'm going to do now is I'm going to show you guys how we can position a user interface inside the world itself. So to do that, I'm first going to take this, this box right here and I'm going to stretch it a little bit, effectively turning it into a nice little floor that we can place some objects on. Then, because we're going to be working with three-dimensional objects, I'm going to come up here to Game Object, select Light, and create a directional light. And since that's so bright it hurts my eyes, I'm going to slightly change the direction of the directional light to give us a nice neutral gray. Then I'll move that off to the side. So let's say that we had a 3D object. Let's say we had a box, a cube, somewhere in our level. And I'm going to position this cube up here at how about 0, 0, 0. And I'm going to move it up. And then I'm going to take my main camera and I'm going to position him at 0, 0, 0. Move him up and move him back so that the main camera can see the cube. Then I'm going to tilt it just a little bit. Tilt it just a little bit, maybe that way too, and move it off to the side. In addition, I am going to go ahead and just create a really quick material called Red Diffuse, and it's just going to have this red color, and I'm going to apply it to my box, just so that it's a little bit easier to distinguish this object. So let's say we wanted to add a GUI to this box. So let's pretend that this box is an NPC, for example, that we want to display some information about. So I'm going to move the game window off to another monitor so we can focus on the scene view. And what I'm going to do is I'm going to create a canvas. In fact, I'm going to come up here to this cube. I'm going to right-click on him, go to UI, and select Canvas right there, effectively parenting the cube to the canvas. Then, on the canvas's render mode, I'm going to change it to world space. Now you'll notice something really interesting just happened, and that is all of the previously grayed out properties on our rect transform are now editable. And because we can edit them, we can manipulate their values, change the width and the height, and even the position of the canvas. And that's because the canvas is now located in three-dimensional space. Generally, what you're going to want to do is you're going to want to come up with a good compromise between pixel value and unit value. And what I mean by that is canvases, even when they're in world space, are still dictated in regards to their width and their height by pixel values and not unit values. They're defined by pixel values where 1 pixel is 1 unit. So that means that let's say I wanted a reasonable speech bubble on a NPC. What would the dimensions of a reasonable speech bubble be? They would be, I don't know, roughly maybe 300 wide by 120. Sure, that's what came out of my fingers, so that's what we'll use. So 300 by 120. Now, if I double-click on this canvas to bring it back in focus inside of our hierarchy, you notice this canvas is still massive. Let's go ahead and try to move it next to our cube. So this canvas dwarfs our cube. It's obviously not going to work very well as a speech bubble because I think it's just a little bit too big. So at this point, what do? Well, like I said earlier, it comes down to a compromise between pixel size and world units. The process that you should go about creating these world space UIs is first determining what pixel size you believe should be appropriate for the widget that you're putting into place. Once you've done that, you should use the scale tool to scale the UI down to an appropriate size. Now there is some math that you can actually employ to make some, pixel perfect sort of guesses as to what these numbers should be. But the easiest way to go about this, as always, is going to be grabbing your resize tool and just scaling it uniformly down. So I've scaled it down. Now I'm going to move it over here. And you know what? I think it's still just a little bit too big. So I'm going to scale it down some more. Then I'm going to move it into my cube, which, since this is a 3D object, it'll be a lot simpler if I go into a top view. and I zoom in on it, and I move it here. And then this view, maybe have it appear to a little bit to the left. This view, make it top dead on, and then we're good. So now you see we've applied a canvas to our cube, and because we parented it to it, as the cube moves, so does the canvas. So what happens when we start to put stuff inside of the canvas? Well, let's start with the panel. I'm going to right-click the canvas, hit UI, and go to Panel. And we now have a panel. Next up, I might want the speech bubble to have the name of the actor. So inside of this panel, I'm going to right-click, hit UI, create another panel. Then I'm going to go to its color and make it kind of black with a high opacity. And then I'm going to come up here to its rect tool and hit Alt and Shift and make it anchored up to the top. Then I'm going to go into my rect tool and resize it. So a nice little title bar for our NPC. Then inside of this, I'm going to right click, hit UI, and add some text. For the text, I am going to set its color to white. Then I'm going to open up its rect transform tool, hold down Alt and Shift, and select this uniform stretch. Then I'm going to change the position, the alignment of the text to the center. And maybe bring his font size down just a tad. And then take his vertical alignment, set that to the center. And then let's give our little box a name. Finally, let's go ahead and on our root panel, right-click the root panel, go into UI, hit text. I'm going to open up the pivot tool, hold down Alt and Shift, and click Stretch Uniformly. And then I'm going to add some padding on the top by just clicking and dragging down. I'm going to add some padding to the left by dragging over, padding to the right by dragging over, and padding to the bottom by dragging up. Then I'm going to type in some text. And now I have a UI element that is inside the world. If I want to see how this looks inside of our game view, I can move it over here. Now notice we are a little awkwardly rotated right now. Let me go ahead and reset the rotation of the camera so we can see a better example of that. So again, we now have a user interface inside of the game world, and it responds by moving the camera. We can see that the UI moves as well. Well, the UI doesn't move, but you know what I'm saying. In addition, if we rotate the camera, it'll rotate appropriately, and so on and so on. Now, it's very trivial to add a little script to our world UIs, our world space UIs, that creates a billboarding effect. And what I mean by that is have it so that the UI is always facing the camera. But anyway, so that's an example of a world space UI. If you want to make more of them, you can just come up here and hit Control D. And we now have another world space UI. And Control D again. And again. So now we can see that these are indeed three-dimensional elements, and transparency works just as expected. So it's an incredibly powerful system right here that we have with our world space UIs. Now you'll notice that I did indeed attach the canvases as children to the things that I want them to be related to. That's just so that if I move the parent, the canvas moves with it. There's no requirement that it has to be like this. We could have the position of the canvas be set through another means, like for example through a script as well. Also, the final thing I want to show you guys is just to prove that these items are interactable. I'm going to open up this panel. First of all, I'm going to set its opacity a little bit higher so that in the game view the other canvases don't make this difficult to see. Then I'm going to remove some words. I'm going to click on the parent panel, right click, hit UI, and let's create a slider. Then I'm going to open up my rect tool and I'm going to move it here like this. Then I'm going to come up here to the panel, right click, hit UI, create a button, and I'm going to move it into here. Then I'm going to come up here. Oh, how about let's make this a little bit more interesting. I'm going to take my camera, move it up a little bit, rotate it down so we have a nice perspective effect on our user interface. Then I'm going to move our game view back over here and hit play. Notice how these items are as interactable as they were before, meaning that you could, for example, create, let's say, a terminal interface for a keypad or something like that and have it inside of the game itself and actually interact with that element as it exists in the game. That's a very common feature that you'll see in a lot of UI frameworks, and hopefully this video shows you guys that putting together such scenarios are actually incredibly trivial with the new UI system. Also, again, just to reiterate that if I were to come up here to my world space camera canvas or my world space overlay canvas and introduce a button, for example, and let's move that button up here, you'll notice that that button also displays as well. Because again, we can mix and match as many canvases of as many types as we want to get the behavior that we're looking for. So some examples of what you'd use WorldSpace UI for, like I said earlier, speech bubbles, in-game user interfaces. Sometimes you have text appearing above characters when they get damaged in, like, let's say, an MMO or an RPG. You could do that with the UI. There's just a whole lot of awesome stuff you can do with the WorldSpace UIs. Anyway, I hope this video showed you guys what you guys can do with putting together different types of canvases. Again, we have 3 different canvases. We have our screen space overlay, which behaves just like the old GUI system. We have our screen space camera, which behaves like a projective projection of our user interface, and then we have our world space. So I think this wraps it up, and we'll see you guys in the next video.